Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I am learning quickly, I don't claim any real expertise. Today, we're looking at the 50th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 50 is consecutive prime sum. The prime 41 can be written as the sum of 6 consecutive primes. And that is those numbers. This is the longest sum of consecutive primes that adds to a prime below 100. The longest sum of consecutive primes below 1000 that adds to a prime contains 21 terms and is equal to 953. Which prime below 1 million can be written as the sum of the most consecutive primes? So, relatively straightforward problem, and I believe we can solve it using a similar strategy, at least for the first part of finding all these primes, as in the previous problem. So first, we're going to go ahead and grab this. Let's just go ahead and grab all of this. Okay, we don't need this one. Our limit is going to be 1 million. And then I think I can do it that way, and then that should very efficiently give us all of the primes up to 1 million. Or all of the primes, I suppose all the primes, up to 1 million, which the number 1 million is not going to end up being a prime, so okay. I think there's a couple of different ways we could approach this. We could start with the sum that we know is prime and try to find whether it can be a sum of consecutive primes, or we can sum up consecutive numbers. Trying to think which approach might be more efficient. Let's see. I'm just going to say for j in range limit -1 to -1. And I'm going to say max consecutives equals 0. Sum prime also equal to 0 for right now. And we're going to walk backwards through is prime. And let's see. First of all, if j... Or actually, I can just make this arbitrarily large. I can say we only care about the sum up to what was the largest one below 1,000. 953. So let's say 950. And I could actually, I'm gonna cut this down to 1,000 so that we can make sure that we get 953. Or, let's see. Yeah, we'll only go down to 100. And what I'm going to do is if j, or if is prime j, then then we want to add up consecutive primes until we reach that number. Actually, I'm just going to do if is prime sum prime equals j, and then print sum prime, just to make sure that we're compiling so far. We are not. Okay. So 101. I was going to include a break statement there. I didn't. That's my bad. Okay. I'm going to change this. No, 100 is fine. We know 100 is not prime. Okay, and how do we find the sum of primes that is equal to j? Nope. My cat would like to be part of this video. Okay, so experimentation is one way, obviously, so we could, like, have a primes if it is prime j, then for gonna say n. For I in range length primes. Equals 0 while sum is less than n. Less than length of primes. I have these backwards, I think. So what I'm trying to do is I'm trying to do some sort of, we start with 2, we sum up, see if we can get to n, then so we iterate through, and then if sum is equal to n, then max consecutives equals equals 1. I'm thinking that this is probably an inefficient way of accomplishing the task at hand. If num greater than max consecutives, max consecutives equals num, sum prime equals n, and then we want to break out of our while loop at this point. And then we are going to actually make this okay. Okay, so obviously this is taking quite some time to run. And it is not going to end up being the way that we solve this problem, I don't think. But maybe just let it go through those. Going back to the problem statement real quick. So we also got an example for prime below 100. So maybe let's make that our limit and 0, and then let's go ahead and pause this and run again, see if we can actually get an answer. Giving it a little bit. This is Samson. He wants to be a part of this. There you go, buddy. Alright. Just gonna give it a little bit more time, but I think that this is just going to end up not working. What I am going to want to do is sort of make this logic. Actually, not like that. Start equals 0, while start is less than length of primes. I equals start. Num equals 0, while sum is less than while let's say for I in range start length primes sum plus equals primes I num plus equals 1 if is prime sum and num greater than max consecutives. Max consecutives is equal to num and sum prime is equal to sum. Okay, so I think that is much shorter code that'll get us to the correct answer. Might still be pretty inefficient, but let's give that a whirl and see if we can at least find the correct number. Okay. So if just gonna say if sum greater than limit, then we break. And also, I never did this part. We gotta reset this. And I want to do start plus equal 1 as well. Even with 100, this might take a little bit to run. Okay, found prime 17 to be the sum of 4 primes, which is the incorrect answer. It should be 41. Let's see if we ever even get there. We don't. Okay, so current sum is sum num consecutives. Ah, I know what's going on here. It's fine. Okay, found prime 41 to be the sum of 6 primes. So, the problem we were having is I was only collecting in the primes array numbers up to the square root of 100, which is a valid way to do this part, but is not a valid way to do this part of getting the list of primes. Now, could I do this another way? Yes. Instead of length primes, I could do limit here and here. Say if is prime I, and then I can go back to having this be slightly more efficient. Okay, so let's see whether that works. List index out of range. Ah. That should be that. Meant to delete the primes array and I didn't, so. Okay. So that at least finds the correct answer for a limit of 100. Obviously, let's look at a limit of 1000. Okay, so took a tiny bit longer, but not much. Found prime 953 to be the sum of 21 primes, which is exactly the correct answer. Now we run it with 1,000,000, see if this works within a minute. I have a feeling it might not, but I was wrong. It took about 6-7 seconds. Okay. 543 primes for that number. Let's see. And it is. Alright. And I have advanced to level 2. So that's pretty cool. Alright, so go through our strategy just one more time quick. Basically what I did is I used the same strategy that Steve of Eros Tamiz, or whatever his name is, to basically just say, let's create a Boolean array of all the primes, and then for all the primes up to the square of our limit, or all the numbers up to the square of our limit, we check whether it's prime. If it is, we delete all multiplications of that. And the reason this works is because the square of our limit is the highest prime that has something else in the array. So I think I can change this to less than or equal to limit without it being a problem now. Since I have the +1 here. Let's double check. And then for the algorithm of going, okay, we know which numbers are prime, how do we know what is the correct answer to the actual question of which one has the most consecutive primes, or which prime is the sum of the most consecutive primes. And for that, what we did is we said, okay, we're starting with 0. And then while that 0 is less than our limit, we set num and sum both to 0s. And then for I in range from start to limit, if I is prime, we increase our sum, we increase the number of primes that we're summing together. If our sum is greater than or equal to the limit, we go ahead and we just break. And actually, I think I can just make that greater than limit now. Just checking. Yep, still the same answers, still a similar runtime. And then if the sum is also prime and the number of primes we've summed to get to it is greater than our max consecutive number, then we replace those. At the end of the loop, we increment start. So we go through this actually 1,000,000 times. We go through this loop with its own inner loop a million times. So it's not a super efficient algorithm, I feel like, but it is working quickly for this. And yeah, then we just print out our answer. We don't have to print out this part, but I wanted to just for my own curiosity. And really, that's it for today. I'll catch you in the next one.